Hey everyone, let's take a look at number 11 in section 3.1. We're going to use the limit definition of the derivative to compute the derivative of this function here, 9, the function f of x equals 9 times x to the negative 1 power at x equal 5. So what is the limit definition? Well, sorry, it's a little messy here. This should be f prime of a, where a is a fixed value. In this case, since when they say add x equal 5, that means a is equal to 5. So in the formula, I think I use f prime of a is some fixed value of x. So x equal a is 5. So f prime of a is the limit as h goes to 0. This is f of a plus h minus f of a. Sorry about the sloppiness there, all over h. So this is what we're going to use to find the derivative. Okay. Now, some of you, again, if you've already seen the power rule, a constant multiple rule, you know how to take the derivative using that shortcut. I mean, that's fine. You know what it's going to be, but that's not what you're doing here. You have to show the support. So on a test, if I say use the limit definition, I will give you the limit definition I want you to use. So you'll have this. You'll need to show the work. And so how do we do that? Well, first note, to make this easier, I think, 9 times x to the negative 1 power is the same as 9 times 1 over x, right? X to the negative 1 power is the reciprocal of x, 1 over x. And 9 times 1 over x is just 9 over x. So this is a better format to write it in. Notice f of 5, because we'll need that here. F of a here, right, where a again is 5. So f of 5 is 9/5, right? Just plug in x equal 5. F of 5 plus h is needed here, right? F of a plus h, again, a is 5. F of 5 plus h is just 9 divided by 5 plus h, right? We're replacing x with, right? We're replacing x here in the input to the function with the whole quantity 5 plus h. So it's not 9/5 and then plus an h. It's 9 divided by the quantity 5 plus h. So, technically there's parentheses around that. Okay, so let's plug it in. So f prime of 5. So here I'm just going to let a be 5. So it'll be f prime of 5 is limit as h goes to 0, f of 5 plus h minus f of 5 over h. So here it is. F of 5 plus h we found is 9 divided by 5 plus h minus f of 5, which is 9/5. Okay, so here's where we're at. And if you notice, if you plug in h equals 0, up top, you're going to get 9/5, right? H will be 0, 9/5 minus 9/5, which is 0. Of course, on the bottom, you'll have 0. It's indeterminate form, right? 0 over 0, as you're always going to get with the limit definition. So that means we've got work to do. Doesn't mean the limit doesn't exist or the derivative doesn't exist. So how can we clean this up? There's two ways you can go. You can combine the numerator as one fraction by combining. Of course, you'll need a least common denominator to do that, which is just 5 times 5 plus h, right? These two denominators have no common factors. And you can combine that as one fraction, and then dividing by h is the same as multiplying by 1 over h. And I show you how to do that in my lecture videos. I typically I do it a slightly different way, and I show that in my lecture videos as well. I'm going to take all my smaller fractions inside this bigger fraction and multiply the numerator of the big fraction and the denominator of the big fraction by that least common denominator. So h is really h over 1. So smaller denominator down here is just 1. But so again, the least common denominator of all my smaller fractions is 5 times 5 plus h. So I'm going to multiply both the numerator and denominator by that. Again, this quantity is equal to 1. So we're not changing the value of this expression. Now we'll do the bottom. H times the quantity 5 times the quantity 5 plus h is just 5h times the quantity 5 plus h. Now you could distribute the 5h through, but I'm not going to do that because I want that factored. In fact, leave that alone. It's factored. Now what happens up top? You see what I have here. How did I get this? Well, again, there's parentheses around this numerator, and we're distributing this whole expression over both terms. When I multiply this first term by this, notice the 5 plus h's will cancel, right? 5 plus h divided by 5 plus h is 1, and you're just left with 9 times 5. What's 9 times 5? 45. Then minus, right? There's the minus 9/5 times this. Now when I multiply, the 5's will cancel. 5/5 is 1. So I have 9 times the quantity 5 plus h. Okay. Now be careful. This is not factored up top, right? This is 45 minus this quantity, which is a product, 9 times the quantity 5 plus h. But 5 plus h is not a factor up top. You can't divide top and bottom by 5 plus h. Okay, that's incorrect. So this denominator is dividing both the 45 and the 9 times 5 plus h. So how do we proceed? Well, let's distribute this -9, right? And be careful, it's -9, the whole thing, over these two terms, and then simplify. Of course, -9 times 5 is -45. -9 times h is -9h. So be careful, it's -9h. And 45 minus 45 is 0. So I'm just left with -9h up top. Notice I don't change the bottom. I keep that the same. But now notice it's factored -9 times h over what? 5 times h times the quantity 5 plus h. So h is now a factor. I can factor out an h of the top, h in the bottom, and I get h over h, which is 1. So I can divide top and bottom by h. And now I can plug in directly h equals 0, right? That was the whole problem. When I plug in h equals 0 up top, I got -9, 5, and then 5 plus h is 5 plus 0. Notice with using the limit definition, what do I have in front of all these equal signs each time? The limit sign, right? Because I haven't evaluated the limit yet. Look what happens here. There is no limit. Why? Because we've evaluated it. You should not have a limit sign here, right? This is now evaluating it by direct substitution, because this function, after we divide out these h's, right? After that, this function is continuous at h equals 0. Okay, so plugging it in then is easy to evaluate, right? We get 5 times 5, 25 down here. So there's my derivative of the function rather at 5, derivative of f prime of 5. That's the first answer they need in this problem. The second one is they want you to find an equation of the tangent line to the graph of the function f at x equal 5. Okay, well, so we need the point, and the point is 5 comma f of 5. Remember, we already know what f of 5 was from above. We did that. It's 9/5. So the point is 5 comma 9/5. And what's the slope of the tangent line? Well, remember, the slope is the derivative, right? The slope at x equal 5 would be f prime of 5, which we found here. So we have our point. We'll call that the x1 and the y1. And we have our slope m. And so remember the point slope form of the equation, y minus y1. What's y1? 9/5 equals m slope, -9/25 times the quantity x minus x1, where x1 is 5. So I have the equation. I just need to solve for y now. Distribute the -9/25. Get -9/25 times x. And then -9/25 times a -5 becomes +9/5, because, right, we can cancel this 5/25 becomes 1/5 times the 9. All right, solve for y by adding 9/5. 9/5 plus 9/5 is 18/5. And there is our equation for our tangent line. Okay, so again, lots of steps in the limit definition. You could check and confirm, if you wanted to, using the power rule to find the derivative, just to check and make sure that you get this. But on a test, if I'm asking for the limit definition, this is what I'm looking for. If you just give the answer without showing this algebraic support, then that would not be what I was asking for. That would not be correct. Okay, I hope this helps.